Hello, let's continue this problem. In the first part, we found this distance B. In the second part, we need to determine the reaction force at O at the instant after the pendulum is released from rest at theta is equal to 60 degrees. So maybe I can copy this again. Okay. So now when the pendulum is just being released, we want to draw its free body diagram. Here the reaction force at O is not purely vertical. It was vertical in the first part because it was designed to be vertical during impact. But in general, before impact it's not vertical. When the pendulum is just being released, there are no impact force. There's just a weight being applied at this center of mass labeled G. So RO we do not know, but in general it has X and Y components. And the weight is along EY. Okay, so if I want to calculate the reaction force at O, one way or one equation that contains RO is the balance of linear momentum, which says that RO plus the weight is equal to the mass of the pendulum times the acceleration of the center of mass. So actually, if we know the acceleration of the center of mass, we can find RO. So we need to calculate AC to calculate RO. One way to calculate AC is by using the kinematics. AC minus AO is alpha cross RC minus RO plus omega cross omega cross RC minus RO. So here, because the pendulum is being released from rest and we're looking at the instant just after it's been released, omega is 0. Alpha, AO is 0 because it's a fixed point. AC is now alpha EZ cross this vector RC minus RO, or RG minus RO in this problem. G and C are the same. Is equal to 0.6 cosine theta EY minus cosine theta EY plus sine theta EX. So I can calculate this cross product. Alpha 0.6 cosine theta EX plus sine theta EY. Very well. So now to calculate AC, I need to calculate alpha. So how can I calculate alpha? Maybe I can use the balance of angular momentum about O. Why not? Since O is a fixed point. The sum of moments about O is equal to H dot O. The only force that has a moment about O is the weight. Its moment about O is RC minus RO crossed with the weight. And that's going to be equal to IOZZ alpha EZ. We do have IOZZ in this problem, and the products of inertia are 0. So then we can calculate that RC minus RO is 0.6 minus cosine theta EX plus sine theta EY cross MG EZ, MG minus EY minus MG EY is equal to minus 0.6 plus 0.6 mg cosine theta EZ. Plugging into the balance of angular momentum and dotting with EZ, we get that alpha is equal to 0.6 mg cosine theta over IOZZ. Remember IOZZ we know in terms of the radius of gyration. So now that we find alpha, we can plug it in this equation and find AC. And from that, we can plug AC into this equation and calculate the reaction force at O. That's it for this problem.